Hello, algebra students. Mr. Lawrence here. Excuse me. And we are going to do some problems here like we've been doing in class. We'll go looking for differences and we'll see what kind of functions we're going to write. So let's go ahead and do that. And so I've got my first set of numbers, -9, -2, 17, 54, 115. You know what, you're a real go-getter. You'll pause the video and you'll try to figure it out on your own. But anyway, here I come with my solution. If you'd like to pause it, do it now. All right, I got x, my input, my f of x is my output, and I've got the first term, second term, third term, fourth term, fifth term, and I'm in search of the nth term, and so I've got -9 and -2 and 17 and 54 and 115. All right, so now I will find my first differences, and that looks like it's a +7, and that should be a +19. And that should be a plus 37, I believe. Yeah. And then plus 61, I believe. Now, if you didn't know, you could do 115 minus 54. And it's okay to use a calculator for some of that. Make sure you don't make any silly mistakes. As I think it was Chris Moyer and Jake Kobaga realized in class on Tuesday, they had made one tiny little mistake, like written down, or it was Derek Hannon, I think. He wrote down 60 in this position instead of 61. And then, of course, nothing came out because he was off by one number. And Jake made a similar mistake. Easy to do. You know, he wrote down, like, instead of writing 7, he wrote 8, and that changed the second differences. And so then things didn't match, and so he was unable to do the problem. So it's okay to use a calculator to check your work. All right, so here we go. We got +12 for my second difference, and then a +18 for my second difference there, and my second difference here is a +24. And then the third differences, since they don't match, I'll go down to the third level. I got +6 and I got +6, and look at that, they match. So since the third differences match, this is something like n cubed. Now, Kaylee, are you watching? I'm not writing 6n cubed, okay? I'll put a coefficient on an n squared later on in this video, Kaylee, but not right this second. So it's just going to be n cubed. All right, so let me see here. So now I need my comparison line. And if I am Dan Michael, to make sure I get it right, I write down here, I write 1 cubed, which of course is 1. And then Dan likes to write 2 cubed, and that's 8, and then 3 cubed, and that's 27, and then 4 cubed, and that's 64, and then 5 cubed, which is 125. And so now I'm going to compare up. How do I turn those green ones into the black ones? You know, this one, I know how to do it. You know, I'm thinking about a number line, and I got -9 over here, and I got 0 here, and I got +1 there. You can think about it this way. I can think, well, geez, this is 9 units away, isn't it? And this is 1 unit from 0. So together they must be 10 units away from each other, right? So I'd add 10. But if you didn't know, you could always do this one, 125 into 15. Ooh, I did that wrong, didn't I? It's not +10, it's -10. All right, 125 into 115, I have to subtract 10. Okay, now you could also do this. You could do 1 plus x equals -9, and then solve for x. And you, sure enough, are going to get -10. Lots of different ways to think about it. Maybe you even have your own. All right, I should check a couple more here. 27, turn it into 17. Looks like I'm going to subtract 10. So it looks like I'm subtracting 10 every time. So that means my nth term is going to be n cubed, take away 10. And therefore my function will be f of x equals x cubed minus 10. I don't know about you, but I really like these. I think they're so simple. All right, let's go on to the next one. Again, if you'd like to try it on your own, I think that's awesome. I really would be proud of you if you did. See if you get them right. Okay, here I am setting mine up, going for the nth term. And then I got 12 and 19 and 26, 33 and 40. And we're going to go +7, and let's see, that's going to be 7 again. Is that right? Yeah, that is plus 7. And plus 7 and plus 7. I guess I was a little surprised because I was expecting something more complicated, but it's actually pretty easy since the first difference is the same. It's an n to the first, but in this case, I do use that 7. I always do that on the linear functions, right? And so I'm going to fill in 7 times 1, which is 7, and 7 times 2, and 7 times 3, and 7 times 4, and 7 times 5. All right, and now I'm going to compare up. How do I turn the green ones into the black ones? I have to take away 5. No, I have to add 5. Have to add 5. Have to add 5. Looks like I'm going to add 5 every single time. So this is 7n plus 5. My function, which is linear, I don't think I mentioned on the last one, it's a cubic function. This one is a linear function, 7x plus 5. And there you go. All right, problem 3. Again, please pause the video, give it a shot. See what you can do on your own. Let's see, f of x. We're going to go 1, 2, 3, 4, 5, and then n. And what do I got? Negative 3, 0, 5, 12, and 21. Make that look like a 5. All right. So we're going to add 3. We're going to add 5. And then we're going to add 7. And we're going to add 9. First differences don't match. I go down to the second differences. Plus 2, plus 2, plus 2. They're all matching. This is going to be an n squared. Now this is really important, okay? Remember the other day I pointed out to you that the coefficient here on n squared is half of the second difference. So it's 1n squared, okay? In this problem, it's not going to show up, but in the next problems we do, it will. So I'm going to take 1 times 1 squared, which is 1. And then 1 times 2 squared, which is 4. And then 9, of course, 16, and 25. Okay. Now, some of you may be wondering why still 1 is unnecessary, but in the next problem, the number there will be very necessary. So how do I turn 1 into negative 3? How do I turn 4 into 0? Oh, I subtract 4. How do I turn 9 into 5? I subtract 4. 16 to 12, I subtract 4. So I'm going to get n squared, or if you want to write 1n squared, that's fine, minus 4. And so my function is f of x equals 1x squared minus 4, or just x squared minus 4. All right, moving right along. Problem number 4. Again, try it on your own. This one could throw you for a little bit of a loop, but you can do most of it on your own. It just will be the end part you'll have a little trouble with. So we've got 3, 9, 19, 33, and 51. Okay, going in search of those first differences. Looks like a plus 6, plus 10, oh, plus 14, and a plus 18, I believe. Don't match, go for the second difference. Plus 4, and plus 4. Now, it's going to be n squared, right? But you see, the coefficient of n squared will be half of that. So it's going to be a 2n squared. Yeah, the coefficient is always half of the second differences. All right, when it's quadratic. So now I've got to do 2 times 1 squared, and 2 times 2 squared, and 2 times 3 squared. By the way, the order of operations is super important right here. If you're not doing the order of operations correctly, you can't do this problem correctly. And it's true of most of math. 2 times 5 squared. All right, so we got 25 times 2 is 50. We've got 16 times 2 is 32. 9 times 2 is 18. 4 times 2 is 8. And 1 times 2 is 2. And check this out. Check it out. I don't know if that's light enough to show. How do I turn 2 into 3? Oh, I add 1. How do I turn 32 into 33? I add 1. How do I turn 50 into 51? I add 1. This is going to be 2n squared plus 1. So therefore my function is f of x equals 2n squared. Oops, that should be an x squared. Sorry about that. 2x squared plus 1. There you go. All right, pretty cool. By the way, you and my first period class are the only classes I've ever taught that to. That's something I just learned from Mrs. Clark about how the second difference is double the coefficient on n. Okay, I never knew that before, and I didn't know how to do problems of this nature. But anyway, now we do, so it's a good thing. All right, here's problem 5. There's actually one more problem after this, if you're wondering. Trying to go as quick as I can. Again, you want to pause it, you go right ahead. All right, and so I got what, 4 and 22 and 52 and 94 and 148. And my first differences, they look like they're 18. And this one here looks like, oh, I wonder if I have a mistake on this one. Looks like it's going to be 30. Okay. On there, it's going to be 42. Oh, no, I guess this is okay. And then 94, 6 to get 154. Yeah, 54, I think, right? Okay, so the second differences will be plus 12 and plus 12. And sure enough, plus 12. So it's an n squared. But because that's a 12 there, it's going to be a 6n squared. I take half of the difference and put it there. Now, I've never explored the relationship with a cubic. You know, like if it's, I suspect it's going to be a 6 times too big. Yeah, I think you're going to have to divide it by 6, but I'm not positive about that. I'll have to explore that sometime in my spare time. So here I'm going to do 6 times 1 squared, and 6 times 2 squared, and 6 times 3 squared, and 6 times 4 squared, and 6 times 5 squared. All right. 5 squared is 25. 25 times 6, 5 quarters would be $1.50, so it's 150. This will be 16 times 6, which I believe is 96. And look at these. They're already close to what we want. This should feel really good. This is going to be 54, and this is going to be 24, and this is going to be 6. And so how do I change the green ones into the black ones? How do I do that? Well, I subtract 2, and I subtract 2. And so I'm going to get 6n squared minus 2. Therefore, my quadratic function will be f of x equals 6x squared minus 2. And I can use that to find any term. Like if I want to find f of, I don't know, let's go with 13. Okay, I would go 6 times 13 squared minus 2. And so this is going to be 169. So I've got 169. And I have to multiply that by 6. And when I do that, I'm going to get 4, right? 54. 6 times 9 is 54. And then I got to carry the 5. And so I got 36, and a 5 is 1. Carry the 4. Looks like it's going to be 1,014. So 1,014 minus 2, which would be 1,012. That's what f of 13 equals. All right, and very important. You do the order of operations. Exponents, multiply, then subtract. If you do multiply first, you're going to be squaring 78, which is very different than squaring 13. Okay, last problem here. No video quiz on this video, just so you know. And let's see here. We got our x term and our f of x. And then we got 1, 2, 3, 4, 5. We're looking for the nth term. And so we're going to get 9, 36, 81, 156, and 245. All right, let's go looking for the first differences. Let's see, that's going to be 27, right? 27, that's a surprise. Oh, let's see, 45. I think that's 45, right? Yeah, I think that's right. 45. Yeah, that should be good. Okay, 56. Let's see, 19 to get to 100. 19. 76. Oh, I've got it lost. Let me do it the old-fashioned way. I'm getting tired. Minus 81, right? So I'm going to get 5. 75. There we go. 75. Okay, that's interesting. That's only 27 there. I wonder if I have a mistake in my pattern. All right, let's see here. I think I do. I think I do. I think I have a mistake. 156. And let's see. We're going to get a 3, and that'll be a 15, so that'll be a 9. Okay, and that'll be a 1. And that'll be an 89. All right, let's see if I can make something out of this. I don't think it's right. I think there's a mistake in the initial pattern. If there is, I apologize. Let's see, I'm going to get plus 18, and then plus 30, and then, what is that? That's plus 14. Yeah, there's a mistake in this one. So we're going to wrap the video up early because this one can't be done during those means. I must have made a silly mistake when I was making up my table. But that's okay. What you learned in this video was that if the second difference is plus 5 every, or excuse me, plus 10 every time, plus 10, plus 10, plus 10, that's the second difference, well then you're going to have a 5n squared pattern, right? If the second difference is plus 14 every time, and this is the second difference, not the first, not the third, the second difference, it's still going to be n squared, but it'll be a 7n squared pattern. All right? Okay, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.